Hey everyone, welcome back. Today we are going to be working on kind of the opposite of what we did yesterday. So yesterday in the problems we would be given an equation of an exponential function and we had to come up with the graph. Whereas today we're going to flip-flop that. I'm going to give you the graph and I'll teach you how to come up with the equation for the exponential function. So we are going to limit this down to only giving you information where you're given the y-intercept, so it'll make it a million times easier for right now. So these are the 3 steps you'll need to follow to write the exponential function when you're given the y-intercept. Step 1 is that we're still using that equation y equals a times b raised to the power of x because that models an exponential function. And we are going to be finding the a value. Remember yesterday we learned that the a value is the y-intercept or the initial value. That always means y-intercept is where x is equal to 0. So you're going to look at the graph, the table, or the list of points. You're looking for where x is equal to 0, which is the y-intercept. That's always your a value. Once you figure out the a value, step 2 is to find the b value. So you're going to find another point on the graph table or list of points and use that other point for your x and your y in your equation, y equals a times b to the power of x. Plug in your x and y, plug in your a that you got for step 1, and you solve it for b. Once you have the a from step 1, the b from step 2, then finally you're ready to write your function in step 3. So you're going to fill in the a value, you're going to fill in the b value, but remember we always leave x and y as the variables. That should seem familiar from back in semester 1 when we were working on equations that were linear. For example, we used the formula y equals mx plus b as one of our formulas for linear equations. Remember that's called slope-intercept form. In that form, you had to fill in m, the slope, and b, the intercept, the y-intercept. You would always leave x and y as your variables. You would fill in a number for m and b, but x and y stay as x and y. You're doing the same thing here. You're going to fill in a number for a and b in your final answer, but x and y in your final answer are just going to stay as the variables x and y. So let's look at an example together. We need to write the exponential function for this graph. So step 1, find a. In this graph, I can see the y-intercept is here. That's where the x value is 0. It's where it's crossing the y-axis is on that point. So I know that my a value is 0.5. Next, I'm going to find b. So I'm going to take another point on the table, graph, or list of points. This one's a graph. I actually get 2 other points. I'm going to choose to use 2, 2 as my other point because smaller numbers will be easier to work with. Since x is 2 and y is 2, I'm going to plug those in to my equation. So x is 2 is going to go here, y is 2 is going to go here, and from step 1, I know a is 0.5. So I will have 2 equals 0.5 b squared. You plug in the x, the y, and the a. Now you have to solve it for b. Just like with linear equations, when you're solving, you use PEMDAS backwards. You follow those steps backwards because you're trying to undo everything. So if you're working backwards here and we're looking at our variable on this right side, we know normally we would do exponent then multiply, but if we're solving, we're working backwards. So we're going to deal with the multiplying by 0.5 first. Ask yourself, how do you undo multiply by 0.5? How do you cancel that out? The inverse of multiply is divide by 0.5. Just like with linear, whatever you do on one side of the equal sign, you have to do it on the other side of the equal sign. So that will cancel out. 0.5 over 0.5 makes 1. But we know we don't need to write 1b squared. We can just write b squared. On the left side, we need to figure out what is 2 divided by 0.5. It might be easier to look at that in fraction form. That would be the same as 2 divided by a half, which we know you keep the first, change to multiply, and multiply by the reciprocal. So we get 2 times 2, or 4. So put in your 4 over here. We have 4 equals b squared, because we really don't need that 1 right there. So what this is saying is that the base squared is equal to 4. If we're working backwards, we did our multiplying. Now we're looking at the exponent. So what base can you square and get 4? What base squared gives you 4? There's actually 2 different answers here. You probably thought of the positive answer, positive 2. Positive 2 squared gives you 4 because 2 times 2 is 4. However, it could also be negative 2 because negative 2 times negative 2 also gives you 4. Take a look at your graph. This graph is going up. It shows exponential growth. So therefore, I know my base should be positive 2, not negative 2. Another way to look at this, if you want to cancel out that squared, if you can't think of it on your own, you're always able to do a square root to cancel out a squared. When you square root both sides, you have to remember put plus or minus in front because technically that could be positive 2 or negative 2. We know both of those. Positive 2 squared gives me 4. Negative 2 squared also gives me 4. So notice you could have found that out by doing the square root of 4, which is 2. Once you find your b value, now you're going to go back to step 3 and put it all together. So now you have your a value from step 1, your b value from step 2. So step 3 is write the equation. You always follow the format y equals ab raised to the power of x. In step 1, you found that a was 0.5. And in step 2, you found out that b was 2. So for your final answer, you should have y equals 0.5 times 2 raised to the power of x. X and y stay as the variables. You only fill in a and b from steps 1 and 2. Now, a quick note on this. Remember PEMDAS. Like we just talked about, exponents come before multiplying. So you cannot simplify this any further. Do not multiply 0.5 by 2 and make that 1 raised to the power of x. This is not the same as 1 raised to the power of x. You cannot multiply before you do the exponent. So since we don't know what the exponent is, you cannot do the multiplication. So you're just going to leave it 0.5 times 2 to the power of x. Okay, now what I want to do is do a little bit more practice, more examples with step 1 and step 2, finding a and finding b, and then I'll give you another one to do all together, like all the way, write the equation. So first, let's just do a little bit more practice with finding a. Let's look at it on a table and on a list of points because so far we've only looked at a graph. If you're trying to find a from a table, remember a is always the y-intercept. You're going to look for where x is 0. Here I see x is 0, y is 1. So in this problem, I know that a equals 1 because that is my y-intercept. This is my y-intercept because x equals 0. Now, if you're looking at a list of points, it's the same idea. If you were given this list of points, you're going to look for where do you see a point with the x value 0? That's this one. I know that this point is my y-intercept because the x value is 0. So for this problem, the a value would equal 4. Now let's do some more examples of finding b. So take a look at these 5 and see if you can figure out what the base would be. For example, the first one is asking you what base do you cube to get 27. Take a minute and see if you can try those. Pause the video if you need to. Here's the answer for the first one. That would be 3. 3 cubed gives you 27. The second one, what can you raise to the power of 4 to get 16? The base would have to be 2. It could technically for this one also be -2, because -2 multiplied by itself 4 times would also give you positive 16. The next one, what base can you square to get 64? That's 8. 8 squared is 64. 8 times 8 is 64. The next one, what can you raise to the power of 4 or multiply by itself 4 times to get 256? That answer is 4. And again, for this one, technically, you could also have -4. Same on the last one, I skipped that. Could also be -8. And finally, the last one, what can you raise to the power of 3 to get 125? That would be a 5, because 5 times 5 times 5 is 125. On these problems, if you're having trouble figuring out what the base is, you are welcome to do guess and check. So go through, for example, is 1 multiplied by itself 3 times equal to 125? No. Is 2 multiplied by itself 3 times equal to 125? No. Is 3 multiplied by itself 3 times equal to 125? No, and so on. You would end up finding out that 5 times 5 times 5 is 125. Okay, now I want you to just put it all together. You're going to have to do steps 1, 2, and 3 on this practice problem, and then you can check your answer when you're ready. Here's the final answer for that. Pause it if you need to. And then when you're finished with that, that's the end of the notes for today. And when you come back, you will be learning more about how to apply these functions to word problems and real life. So I'll look forward to teaching you that soon. Bye.